Most network teams are focused on uptime, but the challenge is that by the time an alert is seen, the impact has already started. Predictive analytics in data center assurance changes this. Instead of waiting for something to break, we're looking at the patterns that indicate something is about to. A transceiver degrading over weeks, memory consumption creeping up below any statically defined threshold, and 5 or more metrics that look fine individually, but together tell a very different story. The goal is simple: see problems before the user does. So here in Marvis Actions, we can see issues that exist right now, and we can use our agentic AI framework to work towards the root cause. But this is where I want to shift focus, because reacting to those issues and finding root cause, as important as it is still reactive. Let's move to predictions. To do this, we use a bidirectional LSTM model, a type of deep learning that reads metric data forwards and backwards in time, learning how multiple signals interact with each other, not just what each one does in isolation. In this bubble chart, the confidence we have in the predictions sits on the left, and the time to failure sits along the bottom. The further to the right the bubbles sit, the more time we have to act, and the higher it sits, the more confident we are in the prediction the system has made. In the case of optical transceivers, what we're forecasting is up to 15 days out using hourly metrics. And because of the bi-LSTM, what we're really looking at in that case is the relationship between bias current, voltage, temperature, transmit, and receive power, all of these metrics together, and not just a single one crossing a line, correlating them and understanding how they work together. Let's click into one of these. We're predicting that the RX power is going to cross a critical threshold within 2 days and lead to user impact. I can see which clients and services will be affected if the optic is left to fail, indicating how long we have left to replace the optic before the failure happens. But let's drill into the interface itself to see the data. Here's what data center assurance has seen. On the left, we have historical data, and on the right of the line, we have our prediction. What you can see is that over the next few days, one of our optical lanes will start trending in the wrong direction. Everything you see highlighted in purple are outliers. They're data points that the model has identified as deviating from what a normal pattern of how a healthy optic should look and behave. We can see that this trend crosses the threshold at which we've previously learnt that optics move from degrading into failing. It's a gradual failure, nothing that would trigger static alarms, but the model has picked up on it. This transceiver hasn't failed yet, no ticket has been raised by a user yet, but we're looking at it now, with days to act rather than hours of downtime and frantic troubleshooting until recovery.